Okay. So, so all we've been looking into is a geographical condition from the cycle one, how the Earth still is going to affect the climate, the elliptical orbit. Next, about the air movement around the building and inside the building. And the third cycle we dealt with the sun path and how this happens, how the shading devices need to be calculated. The fourth one is going to be about the thermal properties. This is more into related with the conductivity. How is the heat gain getting into a building through any openings? What are the ways in which the heat is transferred into a structure? So how the heat flow happens. So these are the conditions. So the reason why we are getting to know about these conditions is, so we know the properties of each construction material or building material, and we know that we'll get to see what are the specifications of them, with which when we are designing, we can use the appropriate material based on a place's climate. You can choose these appropriate material where a less amount of heat is transferred into your building, and the thermal comfort inside the building is achieved appropriately. And this helps in choosing up the materials by reading through the specification also. I don't know how many of us, when we go look into a building material, we look into a quality, we look into a color, but do we look into the thermal properties of a material? So these are conditions which should be specified in this fourth cycle. Is that clear, guys? I'm not getting any acknowledgement. I'm really not sure whether you guys are listening to this. Okay. Um, so here, you don't need to by heart contents. The first point you'll be looking into what is specific heat, what is latent heat. Sorry, that's a typo error. Latent heat and thermal capacity. So you just need to have understanding of these terminologies. You don't need to know much beyond that. And what are the units they deal with? For a reference, a specific heat is the specific heat of a substance, the amount of heat energy required necessary, amount of heat energy necessary to cause the unit temperature increase in a unit mass of a substance. It is measured in joules, kilogram, degree Celsius. So the understanding is, for any material to just have 1 degree of temperature raise for a particularly could be for 1 kg of the material. So that particular heat is called a specific heat. That what is the change value required is specific heat. Just have an understanding, understand what these concepts are, then we can go on to the detail, because these are few things which you just need to know as a superficial, wherein the other later part on conductivity, resistivity and transmittance is, that's why you need to know in much more deeper part. Now, what is latent heat? Latent heat of a substance is the amount of heat energy absorbed by unit mass of a substance at change of state without any change in temperature. So this would be rightly explained. Example, boiling water. So we know water boils and evaporates at 100 degrees Celsius. So what happens? The 100 degrees Celsius remains constant, wherein from the liquid state, the water from the liquid state gets changed into a vapor, a gaseous state. So this is about latent heat. So every material, so the latent heat of water for evaporation is 100 degrees Celsius. So what is that amount of heat energy required to convert? So that is taken in kilojoules. So that is the amount of kilojoules is the amount of work required to get that change. So this again, example is conversion of ice into water. The temperature remains the same, 0 degrees, where from the form of ice, a cube, a solid to a liquid state. So that's about latent heat of substance. What is the thermal capacity? Thermal capacity of an object is the product of its mass and the specific heat. Specific heat is what we looked into the first point. The first one is the specific heat. So it is the weight of the substance with the specific heat is thermal capacity of the body. So the reason why we understand all of these thermal capacities and what are the energy is, so this way we know how much of energy is required, how much of heat is required to cause that changes, and how we're going to work with the materials. So this is the primary factor in which we understand how our temperature, how climate gets affected, how the temperature flow happens. There are three ways in which the temperature heat transfer, any temperature transfer happens is through conduction, convection, and radiation. So this is a very primitive one. Conduction is any surface coming in contact and transfer of heat or cold. That's conduction. Convection is nothing but the air movement, the air which the temperature which the air holds and carries across from one space to another. That's called convection. Whereas radiation is pretty much similar to convection, but only here is the source of object radiating is constant. And example could be a computer, could be a fridge, could be a halogen bulb. So that's radiation. Or object closer which produces heat is radiation. So understanding these three terms is very important for us because these are three exact terms in which we will work on the thermal comfort of the building also. Conduction is, yeah, obviously direct sun rays hitting our walls. We get a conduction. Convection is the hot air from the outside getting into through our openings, building openings is convection. And radiation could be a source from outside, a source could be a household appliance also, can cause a thermal temperature difference. So the motive force of heat flow in any of these forms is the temperature difference between two zones. So what is the motive force? Nothing but why does a heat flow happens? What is on what condition it happens? If two objects are in different temperature zones, then the heat flow happens. And the criteria in which the heat flow in particular happens is the temperature always travels from the higher temperature value to the lower. It doesn't go the other way around. Power is now we get into the heat flow rate. Power is the ability to carry out certain work in a unit time. It is measured in joules per second. So joules is again another value, heat measuring value. If you convert 1 degree Celsius into what is a joules, you will end up with 1600, 800 joules approximately, which is given with watts. So with conductivity, in conduction through a body or through bodies in direct contact, which I already mentioned, the rate. Okay, I'm not reading out what this theory part that you can refer on to the books and you can read out, but I'll tell you what are these conditions which are important for us to look into. The thermal conductivity is represented with the K value. So normally a K representation of value is means of thermal conductivity. So each material will have a conductivity value, as in like could be wood, could be hair, could be water. Every material has got a limitation, and again, this conductivity varies from one is the material, another thing is the thickness of the material. The same material with very different thickness will affect the conductivity ratio also. So the unit of measurement would be watt into meter per meter square degree Celsius. Watt per meter. Simplified calculation, watt per meter degree Celsius. The value varies from insulation material. Yeah. So conductivity, you can note it down. Conductivity is value with the K value. So how do we look into working on a thermal comfort and you're looking to a specification and work on it? If the conductive K value of two different materials, if the rate, the higher the number, then it's got more the conductivity. So in this case, those materials can be avoided to achieve a better thermal comfort in a hot zones. Imagine if you have higher conductivity. My example is, I'll compare with the brick wall to that of just a steel sheet. Could be a container. The steel container is what we are using for a cafe exercise. If you using a brick wall, the K value of brick wall is much lesser than the K value of a steel container. So in this case, the much more comfortable material to choose of would be a brick. So that's how the K value factor plays a role here. For in this case, okay, a steel has got a lesser K value, a higher K value, which means it's got a very high conductivity rate. So has it become a not suitable material for construction? No, it can still be taken up. The only condition is, because since the K value is so much for a steel, what we have to do is we have to bring in an insulation, another material, a glass wool. What happens? The glass will have a very much more lesser K value, so the heat from the steel doesn't penetrate into the inner surface. So that's how the treatment goes. So we work on each of the K value for each particular material, and then we design our building units. So the relevance of density, as I told you, the variation, the thickness or the density of material also plays a very important role in the K value. This is one example they have given. What is the density of the material and what is the conductivity? Expanded ebonite, so 64 kilogram per cubic meter, and the conductivity of 0.29 watt per meter degree Celsius. Whereas the material, the glass wool, which has got a density which is much lesser, has a much higher conductivity value. So you can look into the examples here. Now, what is conductance? So, okay, the resistivity, I just want to bring a note also. Resistivity is the reciprocal of the quantity or the conductivity. So that's why it's 1 by K and measured in the units meter degree Celsius by watt. Better insulators will have high resistivity values. So you can just have a relevance. As in, I told you, what happens with the higher K value? There's more conductivity. So probably it's not the suitable one. So when you're looking at just the K value, we go with the lower value. The lower K value is a good material to be used because it has got a very less conductivity. The opposite of it is the resistivity. So what is suggested here is a material with a high number resistivity value is a better material to be choosing in the case of less heat transfer from the outside. So conductivity and resistivity are the properties of a material. The corresponding properties of a body of a material given thickness is described as conductance. So what they try to say here is, so the conductivity and resistivity thickness which affect the conductance is what is mentioned here. And conductance is again the reciprocal of resistance. Conductance is opposite is resistance. What if it's a multi-layer body? Now we just saw two properties, multi-layer body. If a body consists of several layers of different materials, its total resistance. See, this is a combination which I was saying about a steel container. When there is a steel container, the outer surface is steel, and what happens to the K value? Probably you can take the resistivity value. The resistivity value is very less for a steel. So, in this case, to maintain the thermal comfort, what is suggested and taken up would be use a insulating material. There are various insulating materials. One could be a foam, one could be a glass wool. So another material is brought in. So that has got another resistivity value. a glass wool or a foam's resistivity value is much higher when compared to steel. Okay, that is fine. But having this glass wool or foam on an exposed surface is not aesthetically pleasing. So what we do is we do a plywood paneling or on any other surface paneling, which again this material would have. So this becomes like a sandwich of 3 or 4 materials together. So in that condition, how the resistivity is calculated is its total resistance will be the sum of resistance of individual layers. That is the individual materials. So that is the way in which you calculate. The conductance of a such multi-layer body can be found by finding its total resistance and taking its reciprocal. It can't be, the conductance can't be taken as a additive. That's what is being mentioned. And only the resistance can be added up and can be taken as a value. And the reciprocal of it is taken as assumption for conductance. In surface conductance, the resistance of a body, in addition to the resistance of the body to the flow of heat, a resistance will offered by its surface. A very thin layer of air or film separates the body from the surrounding air. This measure of this is surface of film resistance. Surface conductance includes the convective and the radiant components of the heat exchange at the surface. So the surface conductance is nothing but, even though the material by itself has got a quality to conduct, the surface, again with a thin layer of air on it, it's got another property where it still objects and how it's going to take up. The heat flow from one surface of the body to the other surface was considered. Thus, the temperature difference was taken based on 2 square. Conductance is defined. That's not okay. So now we get into the overall air to air resistance. Air to air resistance is the two spaces where the surface resistance and the body resistance comes into the sum of both. The body resistance and the surface resistance brings to a air to air resistance. Air to air resistance is more like a convection, as in like you have a hot air coming in, how you're going to stop it, how that hot air eating a surface, how it's going to reduce the heat, pass on the heat, is the air to air resistance or is the air to air transmittance. So, as I told you, in a space, when we have definitely we have to have openings for a cross ventilation and the good habitable space. So, there are two things which can happen is the air to air resistance. If the space is very cold on the inside, and we keep our place all the windows shut and we're going to keep the place like that, so it's comparatively cooler till the time the breathable air is going to be hot. But if the openings are being taken out, so definitely, as I told you, temperature always flows from the higher rate to the lower rate. The temperature is the indoor temperature is low. When we open up the windows, the hot air from the outside is definitely going to come in and it's going to increase the value. So this is a air to air transmittance. Here there's no other source of object, just the air movement from the outside changing, getting into the inside will have a transmittance. So this transmittance of heat through convection is what we call as a transmittance or U value. Again, this is one important condition parameter which we look into almost all the materials: glass, wood, brick, clay blocks, tile, steel. Every material have a U value, and appropriate to the U value, we can choose the condition on what basis we need to have a layer. The unit of materials conductance same as the conductance. There is a high temperature difference. So you don't need to read off all of these theories, but just to have an understanding of what are these important terminologies which is required. U value of a non-founded table. Okay. These are few examples of a transparent using. These are few values which are mentioned here. The transparent U value of the interior wall construction cannot be found quickly. Calculate. Um, Assume a wall of westerly or normal exposure consisting of the following: 114 mm engineering brickwork, It's got a value, U value of 1.150, a 50 cavity RC. A 50 cavity is just a space. It's got a U value which is much lesser. A 100 dense concrete. The conductivity rate is more. So here, when you look into the U value, you can see there are two conditions in which we have to work with. The thickness, every thickness, as in a brickwork of this so and so thickness has got a particular value. But the same object, if the brickwork is increased to a much more bigger thickness, then it will have a different value. That's why the reason is we are just not looking at the values on the end alone. We are looking at the values on the front on what specification. How these U values are calculated here. Just I'll show you a better reference for the U value, which I already picked it up. So as of now, you don't really need to be calculating on all of these values, but just to have an understanding of how each material, what are the values being specified. Okay. This is a quick find. This is a website, it's a UK-based website, but this is just for a reference or understanding on how these values are being put up for various materials on a very summarized manner. A solid brick wall has got a U value of 2 watts per meter square. It's given as Kelvin. We use as a degree Celsius here. So similarly, a cavity wall with a low insulation is got much more lesser U value, 1.5 watts. Thing is, so which means this is much better than the solid brick wall with a cavity wall alone. There's no insulation. In a cavity wall, the air gap between the cavity in the cavity works as an insulation. This is on an insulated wall. You can see how drastically this value is reduced down into 0.18. So this wall has got a better resistance of thermal resistance from the outside. Just a single glazing. Single glazing is just a single pane of glass. You can see what is the higher the U value, it has got so much of transmittance from outside to inside, 4.8 to 5.8. Now, because of this transmittance, definitely we need to opt for another mode of thermal comfort, as in we have to look into air conditioning to cool down the spaces. Imagine if it's going to be a double glazing, it has worked out to be much more lesser, depending on the type of glazing. It can range from 3.7 to 1.2. Triple glazing is 1. A solid timber construction gives you 3. So with this, I just want to give you this understanding. So the important point to be noted is, again, with the U value as a resistance, the lesser the value for specification for each material is better for the achieving a better thermal comfort in the space. So with this, we'll stop today's session. I want you guys, because since no one gave me acknowledgement, I'm really not sure which part you guys understood and which part you guys have questions. Can you ask questions, please, guys?
Sir,
Yeah,
sir,
yeah,
hello, sir.
yes,
Uh,
Akshay.
uh, sir, what is resistance, sir? Actually, I got a doubt in that part. Resistance.
Resistance is the conductance is allowing a transfer of heat flow through the body. As I told you, the heat flow normally, example, plastic bottle, water bottle. If I'm going to have a hot water put up in this particular type of bottle, the hot water, the water is hot on the inside. Because of the heat, the temperature is more on the inside than the temperature on the outside. So it's going to conduct heat through this plastic, which I can feel it with my hand. That is conductance. Okay.
Yes, sir.
The inverse of conductance is resistivity. Example, if this bottle is replaced by a metal flask, a heat flask, what happens? Even though there's
Yes.
water, hot water on the inside, we won't be able to feel the heat on the outside, right?
Feeling outside. Yes,
Yes.
sir.
So this is the resistivity. The material's ability to
Yes, sir.
hold the heat within itself.
Yes, sir. Yes.
Okay.
I got it, sir. Got it, sir. Thank you.
Guys, were you all able to understand? So the important things you need to understand from today's session is conductivity, the K value, resistivity, which is the inverse of conductivity, and how to calculate uh, um, conductance for a multi-layered body. And the last part is a transmittance, the U value. So these are few parameters which you need to know theoretically, as in just as a knowledge. You don't need to by heart any particular formulas, but all you need to know is the meaning, the definition for these terms. And these are very probable questions for 2 marks. And another one part is to the definitions, you need to know what units they work in. Those are the few things you need to know. Even though I've got picked up all these theoretical content, those are not required as of now. So, any questions, guys? Did anyone try working out the shadow angles from the last class? Sorry, I posted the video today, but other than that, anyone tried doing it? Okay, probably you can look into the video tutorial today and try finding one of the values. So, any are there no questions or queries at all from the session, guys? Okay, fine. Okay, guys. So, we'll end the session for today. And if you have any queries, do let me know. Do reach me out. Okay. Do mark your attendance in the GCR. I uploaded the attendance there. Thank you for joining the session. Thank you, guys.
Thank you, sir.
Yeah.
Thank you, sir.
Yeah.